To introduce the shape of a logarithmic function, we want to begin by reviewing the basic shape of an exponential function. So we'll start by graphing f of x is equal to 2 to the x power. In other words, we're graphing y is equal to 2 to the x. So remembering that in this case the base is 2, and because that base is a value that is greater than 1, we know this is going to be an exponential growth function. So if necessary, if you need to go ahead and make a table, that's fine. We can make a table to generate the basic shape of this graph. And starting from -2 to 2, kind of our traditional table is just fine. So remembering 2 to the -2 power is really going to be 1 over, or 1 divided by, 2 squared, which is really going to give us 1/4. So -2, we should have 1/4. 2 to the -1 power will be 1 over 2, or 1/2. 2 to the 0 is 1, 2 to the first is 2, and 2 squared is 4. And in fact, on most of our graphs, if we're using a grid that goes from -10 to +10, we probably also have room to go ahead and go to x equals 3, because 2 to the 3rd power will give us 8. So we'll go ahead and plot those points, and hopefully the basic shape of this graph is not surprising. So at -2, we're just barely above the x-axis at 1/4. And at -1, we're at 1/2. At 0, we're at 1. At 1, we are up at 2. At 2, 4. And finally at 3, there it is. And at 3, we're up at 8. And now hopefully you can see that basic exponential growth shape which we expected. So this is the graph of y equals 2 to the x power. Now let's also review the basic features of the exponential functions, and it doesn't matter whether it's exponential growth or exponential decay, they have the common features. So we know that we have a horizontal asymptote. I'll put my features over here off to the right. I know that I have a horizontal asymptote. I'll write HA, horizontal asymptote, and my horizontal asymptote right now is y equals 0. Now, of course, when I shift the graph, the horizontal asymptote may change if we shift the graph up or down, but we're talking about the basic parent functions. They'll have a horizontal asymptote of y equals 0. We have that common point 0, 1, which is our y-intercept. So our y-intercept is the point 0, 1. The domain for this function, the x values that are possible, we can enter in any x value we want. So my domain, if we look at the graph from left to right, is all real numbers. And then my range, lowest to highest, is going to be from 0 to infinity. And you'll notice that the graph actually never has a y value of 0, so we have a parenthesis on 0 because, again, that was our horizontal asymptote. And the graph is never going to intersect its horizontal asymptote. So those are my kind of 4 basic features of an exponential function. So now we'll move on to part B, which is asking us to graph the inverse. And I'm going to change the color. I'll be graphing the inverse in red. So we know to graph the inverse, we're going to interchange x and y. So using my original function, instead of f of x equals 2 to the x power, let's use y equals 2 to the x power. Because if we interchange x and y, then that means that we're going to be graphing x is equal to 2 to the y power. That would be my inverse. So taking a look at the table that I've already generated, we can use our table to help us graph the inverse by just simply switching the x and y values. So instead of -2, 1/4, we'll be graphing 1/4, -2. And so just interchanging all x and y values, we'll have 1/2, -1, 1, 0, 2, 1, 4, 2, and 8, 3. So just interchanging x and y yields my new table of values, and this is going to help us generate the inverse. So let's go ahead and plot those points. And again, I recommend doing that in a different color. So we have 1/4, right 1/4, and down 2, -2, 1/2, -1, 1, 0, 2, 1, 4, 2, and 8, 3. And graphing, connecting those points, you'll notice that this curve is going to get really, really close to the y-axis, but not intersect it, and has that basic shape. So remembering that a function and its inverse, they're always going to be reflections over the line y equals x. So hopefully the basic shape here looks good to you. And what you've graphed here in red is the graph of a logarithmic function. So you just graphed your first logarithmic function without really knowing it. And this is a big idea. The relationship between an exponential function and a logarithmic function is that these are inverses of one another. They are inverses. So for part C, to write an equation for the inverse, we can take what we started with here. Our equation was x equals 2 to the y power. And all I'm going to do with that equation is just rewrite that equation in log form. So if you take this equation and rewrite it in its logarithmic form, notice the base is 2, so that's going to be log base 2 of x is equal to y. And this is the curve that you just graphed. You just graphed y equals log base 2 of x. That's my red curve. And that's going to be the equation for the inverse. So when you take a look at the common features that we listed, sorry about that, if we go back, look at these common features, the 4 that we listed up here for exponential functions, we now can make a similar list for logarithmic functions. So now that we know a logarithmic function is just the inverse of an exponential, then instead of having a horizontal asymptote of y equals 0, we know that logarithmic functions are going to have a vertical asymptote, and the equation for the vertical asymptote will be x equals 0. And you can see that graphically. You can kind of see right here, if I were to draw in this dotted line in yellow to represent the vertical asymptote, you see that my graph is getting very, very close, hugging that vertical asymptote, but never intersecting it. So going back to my list, I had a y-intercept of 0, 1, so now switching x and y means I now have an x-intercept, and my x-intercept will be 1, 0. And you can see that point right here on the logarithmic graph. The x-intercept is 1, 0. Then domain and range are also going to be interchanged. So my domain is now going to be from 0 to infinity, and my range is going to be all real numbers. So we have the 4 common features of a logarithmic graph just by comparing them to the 4 common features of an exponential graph. So here are my logarithmic features. So big idea from this introduction into the shape of a logarithmic function and its graph is that an exponential function and a logarithmic function are inverses of one another.